Good day, everyone. Have you ever used Gmail, Dropbox, storing things in Google Drive, or watching videos on YouTube? These are the things related to cloud computing. So, what is cloud computing? Simply put, cloud computing is the delivery of computing services, which include servers, storage, databases, networking, software, analytics, and intelligence, all over the internet, which can be said as cloud. It offers faster innovation, flexible resources, and economies of scale. It is named as such because the information being accessed is found remotely in a cloud or in a virtual space. So whenever we access the cloud, we will be generating the loads. And sometimes when more users, the loads will be generating more and traffic occurs. Cloud managing workload in the real world is commonly in the form of queues. However, load patterns in previous studies show less similarities in real traffic, as data fitting in a capacity planning model must be realistic, which has to follow the fundamental principles. Capacity planning is a well-known method that is dynamic in the computer system fields, especially in cloud computing. Characterizing the workload and modeling the workload are essential steps that are required in capacity planning. So, to mimic the real-world traffic, queuing theory will be applied in the model for capacity planning in cloud computing. As mentioned earlier, the cloud managing load is in the form of a queue in real traffic. Therefore, queuing theory models are more realistic and more suitable compared to other theories. The aim is to apply the queuing theory to the characterized cloud load if possible. Queuing theory is based on real-life scenarios of the queue or line. In the example of a computer system, the client will be sending a response to the server. Then the server will be receiving different requests from the client and process the request. So the request will be in the form of a queue that will be waiting to be responded. In this study, we'll be applying the single server model and also single queue model, also known as M/M/1 queue model. If possible, we'll be doing multiple queue with a single server model. And how should the simulation be? So this will be the environment setup. The outer box, as you can see, is the operating system, and we'll be using Ubuntu. Since the cloud is a virtual space, therefore there will be two virtual machines, one for generating the loads, or can be known as the client, which is the left box. Another one will be managing the loads, also known as the server, which is the right box. The load generator will be using either WRK or Locus software. The server side will be implementing Engine's open source software, which can operating services and delivery content, and also MySQL databases. As for the tunnel, we'll be applying KCP, which is known as Kernel Control Protocol, since it is much faster than TCP. As for the result, the aspect of the analysis will be the mean waiting time and also the server utilization. The comparison will be showing which model references the real-world traffic the most. The conclusion, the queuing theory model should be able to be implemented in cloud computing. As for the future scope, the simulation will be run successfully and other models will be comparing to determine which model is the most suitable for real-world traffic application. As for the future improvement, I hope that it can increase the queuing line without affecting the server utilization and also increasing the efficiency of the proposed model. That's all from me. Thank you.